another challenge. Now we have another challenge. So you know that the city town hall has decided to build a park in the center of the city. So this is a park. Of course, it will occupy some spaces, and they have to merge some streets into the park. This means we don't have any longer these streets go through these points. So we have a square, a bigger square, which is not accessible. We cannot enter it, yeah, in other words. And now how many passes are there from P to Q? It's not the same as we have learned to count the intermediate points, but now some points are not possible. In this case, we have to think about, of course, the green rectangle still works, yeah, meaning that we cannot go outside of this green rectangle. Otherwise, we'll have a longer journey, yeah, a longer way around. So that still works. And what else is that we see the A, B, C, D, which are the intermediate points. For each pass from P to Q, we cannot avoid any pass out of these 4 points, meaning that each pass will go either via A or B or C or D. It's just like a must be intermediate stops, right? And you will ask, why A and B? Why not these points or these points? Because you see the direction from P to Q is also from the west-south to the northeast. So it's natural to have such a intermediate stops with the same direction. Otherwise, if we say, okay, we choose these 2 points, and then we can find a path through it. Let's change my pen. Sorry, I'm going to change my pen. Yeah, so why not this one and this one? If we choose these 2 points, meaning that you see we can find the path, go to the Q, yeah? We can avoid these 2 intermediate stops. So we have the name A, B, C, D. So you cannot find any way which can bypass these 4 points. Okay, now we have a good solution for this challenge. We can divide this problem into different passes. Since each pass from P to Q must via this one of these 4 intermediate stops. Then we have 4 cases. Yeah, we have 4 cases. One case is that the path is via A. Then we can use again the rule of products. Yeah, for any path from P to A, we count. Okay, that was six passes. 1, 2, 3, 4, 5, 6. And from A to Q, they are in the same street, only 1 possibilities. So we use the rule of a product because we have intermediate stop. So from P to A to Q, there are only 6 passes. Yeah. And now we're counting the second case, the path through B. If the postman gets Q via B, then we count from P to B and the B to Q. So the same similarity, we have 15 passes from P to B and 6 passes from B to Q. So in total, there are 90 passes. We do the same for C and D. And at the end, we use the rule of addition. In which cases we use the rule of addition is that if you have different cases, you have to go either this way or that way, then you have the rule of addition. But if you have a job to be done in different steps, step 1, 2, 3, and ends, you have to use the rule of products, right? You have to do the first step, multiply by second step, multiply by third step. And in this case, we have 4 cases, and in each case, we have 2 steps. Yeah, in each case, we have 2 steps. So we first use the rule of product, calculating the number of the passes for each case, and at the end, we use the rule of addition to sum them up. So at the end, we have 132 passes. It will be much less than